Okay, in the Thevenin theorem, when you will going to do in MATLAB, so what you will going to do? Okay, draw one circuit. I will going to draw one circuit. Once like about resistance. Okay, followed by the source. Okay, then here is one more resistance. I will going to connect. Okay, then here I will going to connect another resistance. Okay, and then here one more resistance. Okay, so like I will going to connect it. Okay, so that's all. Okay, so this is one circuit. The values, for example, 2, 4, 6, 8, 10, 10, 12, 14, 16. So 16 is a load resistance. A and B they will going to mention. So it's a given circuit. So this circuit you will going to verify the Thevenin's theorem using the MATLAB. So using the MATLAB it is used to you will going to verify. What is the step number one? So step number one is what is the step number one? So load, where is the load point? Load point remove. Okay, across that one you will going to connect the voltmeter. Okay, so step one, what you want to do? So okay, I will going to redraw diagram for your understanding. Okay, what to do? Okay, load terminal is need to remove. Okay, so this is a 4 voltage source followed by the 6, 8, then 10, then 12. Okay, then this is a point is a B. Then if you want to connect the resistance, even the resistance is no use because it is open circuit. A you can write A and you can connect the B. Okay, then here you will go and write a 2, 4, 6, 8, 10, 12. You will go and write. Okay, even if you want this resistance also you may connect it, no use, even though if you are interested you can connect. So step one, what you will going to do, take one voltmeter. Okay, just to take one voltmeter. The voltmeter has that two terminal. One is connected to this point, another is you can connect to this point. That's all. So in that method you will going to measure. Okay, so it will going to display the voltage. Assume it is displaying on the 12 volt. So that's all. So you will going to note down the values of that 12 volt. Step 2, find out the R equivalent or RTH. So RTH, what is that one? Load should be removed, the voltage source is a closed circuits. So no, practically you can do with help of the multimeter, but a simulation it is not possible. Okay, then step 2 you will going to do yourself only. Step 2 you will going to do yourself and find out the what is R equivalent. Then what to do on the step 3? Step 3 you will going to do here. What is step 3? What is the voltage you found? 12 volt. Then write it that 12 volt. Step 3 directly will going to come here. Okay, voltage source. They set the value is 12 volt. After setting on that one R resistance, theoretically you found about the step 2 R equivalent and substitute the R equivalent value. Okay, just double click and then give the value and then RL. One more resistance you can keep. The resistance value is 16. Okay, then in the circuit I want to measure the current. Then one ammeter connected here, that's all. One ammeter connected in seriously and is measure the current directly. That is a load current. So this is about that one practically what to do on that one theorem. So this is sample. So similarly you will going to do for that remaining theorems also as similar. Okay, so it is a similar the same method. Voltmeter, you know, you need to know how to connect the voltmeter and how to connect the ammeter. Okay, so the unit name is called a transient response. You know, this is a unit number 3. Then another unit also the same. It is the same. What is that one? Here in that unit, what you will going to see the same following on that one you will going to do on that next unit. So this is the content about the transient response. What is that one? Three content. One, two, three. Three content is there. Only three content. What is the first content? RL circuit. RL means what? Resistance and inductance is connected. Okay, seriously connected RL circuit, RC circuit, RLC circuit. So only this is a thing. See, two element. One is resistance and inductance is connected in series to the DC circuits. Okay. So it will going to connected, you will going to give the power supply to the DC circuits, RL, RC and RLC. So this is a different of that one, resistance, inductance, resistance, capacitance, resistance, inductance and capacitance. So you will going to connect it. Then what you will going to see, so it has that one two top, I mean, everyone it has that one two. Okay, one is a simple DC excitation. Okay, you will going to directly apply the DC excitation to the RL circuits. Then second one is what you will going to apply means, so you will going to see about the source free. Source free means no source, and or it is another name is called undriven circuits you will going to see. So similarly RL means RC also same, but RLC no. Okay, I will repeat you again. So every RL also two circuit, I mean, two derivation, RC two derivation, RLC is the only one derivations. But one more is the introduction derivations. Okay, first derivation. What is the first derivations? So this is about the first derivations. DC excitations. So you will going to apply the DC excitation through the switch R and L. So this is a element, two element R and L is connected in seriously, it is connected. Okay, so you will going to apply the DC source. Yes. So then you will going to write the equations. Okay, what is that one final equation? I of t you will going to find out. That's all. So this is your target. So you will going to find out the I of t. So first one, this is our derivation number one. Derivation number one, you will going to do, you are going to learn. You are going to learn on that one. Okay, I will repeat again. DC excitation, DC power supply, you will going to apply to that RL and find out the transient response. Okay, find out the transient response. So this is a derivation one you will going to learn. What is the derivation two? You know. Okay, okay, same RL circuits or L circuits, source free. Source free means no source or undriven. It is another name. It is called undriven. See, the switch is moved from A to B. The switch is moved from A to B means what happened? Initially, the position of the switch is A. Okay, T is equal to 0. Switches is moves into B. Switches is at a term at a time period T is equal to 0. Time period T is equal to 0. Switches is moves from the A to B. So now it is a B means what will happen? It is nothing but it is a closed circuit. Closed circuit, already stored energy it will going to dissipated through the closed path. It's a closed path. So through the closed path it will going to energy is dissipated. So what will happen? Okay, at a time period t is equal to 0, so the circuit is closed like only. It is a what will happen? It is a one closed path. Does it contain any source? No. So no source, that's why it is called as a source free, or another name is called undriven. They will going to say, okay, what to do, it will going to do means it will go to energy during the A condition, stored energy during the B condition. What will happen, or mode 2 condition, it will going to okay, dissipated through that one loop. It will going to energy, it will going to reduce or dissipated. It will going to store the energy, it will going to reduce, dissipate. So we will going to derive the derivation. That's all. This is the second derivation. That's all. So this is the, like, you have the two derivations you are going to learn on that RL circuit, RC circuits. So only this is a major things. RC circuit also same. Derivation number one. Okay, excitation. Okay, derivation number two. What is that one? It is moved to that B. Like you will going to say, you will going to learn. Okay. Then similarly RLC basic about that one you will going to second order you will going to learn, and followed by the your derivations RLC DC excitation you will going to learn. Okay, so this is only about your third unit, transient response. So what you are going to learning in the content I covered you. So one there is a three topic: RL, RC and RLC. So three topic. One is a with DC excitation, another one is a source free or undriven DC excitation. Okay, source free or undriven, okay, excitations. Okay, similarly here DC excitation, source free or undriven. Here you will going to you are going to see about that only DC excitations. So you will going to learning about that. You are going to learn here derivations. You are going to learn about the derivation here. Okay, so you are going to learn about the derivations. Okay, so before we go ahead on the derivations, so what you want to know? Well, first, basically, what is here the title? It is saying transient response, or it is saying about the transient response, and one more response is there, that is called steady state response. Okay, so here you are going to learn about that one. What is transient? What is steady state? You know that one in control system. I said about that one. Okay, there is a lot of responses are there. So transient response, steady state response. Okay, delayed time. In that one is starting is called a delayed time, rise time. Okay, peak time. See the in that point. Okay, in that point it consists of three times. So delayed time, rise time, and the peak time. See the my mouse is moving. So delayed time. It is starting point is a delayed time. Then rise time, peak time. Okay, this is a peak time. Or you will going to say about the settling time. See, even your next power electronics also you are going to learn. You are going to study about the graph. So like about that one. Okay, turn on. The turn on. This is a turn on process. It's a move from here to here. Okay, the circuit is how it will going to turn on. So zero to this a point. It will going to variations. It's move from one state to another state is moving linearly rise. What about that one? Linearly it will going to rise. So it is a move from one state to another state means that is called a transient state. Okay, see here I have written transient state. What is the state? It will going to change from one state to another state. What it will going to change? Either the voltage or current. It will going to change. Here is what is the parameter is written? Current is written. Either current or voltage, whatever the parameter you can write. It will want to move from zero state to another state. What is the state here? One state. It's a move from zero to one. And this is called a transient state. What is the time? Transient time. It's similarly it is change from one state to another state moving time. So what is the time? Here is a 0, here is a 0.1. So it is moving from one state time to another state time. That is called a transient time. Okay, so this is about the transient response. What is the steady state response? Steady. So it is a constant. It is a constant mean that is called a steady state. So you have see that one. Okay, constant amplitude and frequency. So that is about you will going to write here. So what is our parameter? Constant. So amplitude or frequency of the sinusoid never change. It will going to never change means it is a constant one. Okay, current or voltage do not change with respect to time. So your parameter is here is current. It is not vary with respect to the time. Here is what is the time? 0.1 second. What is here? It is a 0.5 seconds. Does it is change? No, it is not change. It's a constant. That is called a steady state. So it's a basic about the transient state and then steady state. Okay, we go to that oral derivations. Before you are going to proceed about oral derivations, so you should know about that one small derivation. This is a small derivation about the homogeneous and non-homogeneous. Why do you want to know about homogeneous and non-homogeneous? Means you will going to compare that one this equations. Okay, the derivation you will going to derive. Okay, simple kvl method too you will going to derive. So I will going to derive the equation. This is equation number 1 and then divide by l, and equation number 2 I will going to get. After getting this equation 1 and 2, I will going to compare with the non-homogeneous differential equations. I will going to compare with the non-homogeneous. Where is that one? It is a homogeneous. What is the here is a non-homogeneous. I will going to compare with the equations. So I will going to compare. So I will going to write about that a non-homogeneous equation here. In that box is represented non-homogeneous equations. I will going to compare equation number 1 and 2 with respect to 1 and 2. Okay, when I will going to compare, then I will going to find out what is a p value and what is a q value. I will going to find out, and then once I will going to find out, I will going to substitute into that one these equations. Okay, from that one I will going to find out what is a p and what is q, and a substitute. I will going to get the equation. This is about my current equations. So this is my current equations. I will go to equation number 5 I am giving. Okay, in the equation as usual switch is closed. Now I will going to go to that one. If it is a switch is closed at the period of the t is equal to 0. So during the time at the time of closing I is equal to 0. So at the time of the closing immediately the inductance is never charged. So immediately switch is closed means it has inductance, it will going to get the charge means it is taking some time. So that's why so current is equal to 0. Substitute on that one t is equal to 0, I is equal to 0 in the equations. Then you will going to get the constant value c value. After get the equation number of the 6, substitute into that one in the equation number 5 c point I will going to substitute it. So once I will going to substitute it and I will going to simplify what is my equation is I am getting, this is the equation I am getting. So I it is equal to v by r, open the bracket, 1 minus e power minus t by tau. It's a constant. Okay, so what is a t value? Okay, so t by tau I will going to I put it on the constant, this is a constant. So I will going to replace into the 1 Okay, I will going to replace 1. E power minus 1. What is the answer? Use your calculator. E power minus 1 means 0.368. Then 1 minus 0.368 means answer is 0.632. Then V by R. So Ohm's law, V by R means I. That's all. So I of t is equal to 0.632 I of S. So this is about the equations. So I of t equation I will going to derive. So this is a method about derivation of I of t. So you will going to compare with the non-homogeneous equation and then you will going to derive. So this is one type of the derivation or one other method also there. So like the derivations. Okay, but this derivation is not completed. Derivation is continue. I of t you found. Yes, here is I of t I have found or the equations. This is the equation I of t. You can take any one of the equations. Yes, I of t equation I found. Okay, I of t multiply with the r. So I multiply r means that is called a v. So v of r. So you will going to get v of r. Next one VL. What is the general equation? VL means L di by dt. L di by dt. This is the general equations. How the Ohm's law V is equal to I and R. V of L means L di by dt. You were learned about the first unit. Okay, I show you one tabulations. In that one tabulations, it will going to show you VL. L dot di by dt. Substitute the I value. What is I value? This is I value. V by R. 1 minus e power minus. Okay, here the seventh equation. So okay, before the steps. So substitute that one I values, then simplify. Then you will going to get VL. So VR you are getting, VL you are getting. So two equation VR you are getting, VL you will going to get. So can you find out the power? So power is equal to what is the formula? P is equal to PR plus PL. Okay, resistance power plus inductance power. So you will going to find out the PR first, then followed by the PL first, next followed by the PL, then substitute. Then substituted then means you will going to get the equation of that power equation is over. So you will going to do on that PR, then PL. What is the power? Power is equal to V into I. What is here? R, resistance. Resistance means VR into I. So you will going to multiply. Similarly, PL means similarly V into I. So VL into I. That's all. So like about that one, you will going to complete about the derivation. This is about the derivations. Okay. So for that one, yes. Otherwise, another method also the same problem. So you will going to solve with respect to another methods. Okay, so another method used to you will going to simply you will going to derive about that one. That is also okay. So you have the two possibilities of method to you will going to comparisons with respect to you will going to find out the answer or simplify. So simple you will going to simplify to you will going to find out the answers. Okay, I will teach you about this that one also. Okay, so this is about the derivation number 1. Derivation number 1 about the RL excitations. Okay. Okay, so this is about your unit, and before you are going to proceed about that one, so first are differential equations you were studied in mathematics. Okay, homogeneous, non-homogeneous. So you should be know about the derivation about this is the things also. Okay, homogeneous means what? V of t is a general equations. Okay, in the take about the general equations. Okay, in the general equations, the homogeneous means V of t is equal to 0. You can substitute. Where is the V of t? Here. The point is you will going to substitute into the 0. Okay, as usual, you will going to proceed. Okay, I will going to shortly tell you. So V of t I will going to substitute this point. Then what is the remaining on the left hand side? The same it will going to come as in the left hand side. Okay, then I want to keep it under the A not into di by dt on the left hand side. A1 and I of t move on the opposite side. So plus this term is move opposite side, minus terms. Okay, then I will going to keep it uh, di by dt on the left hand side. This a naught I will going to move opposite side. So it is a multiply term. So come here this one denomination it is coming. Then after that I will going to put the circle these two I want to interchange. I of t is coming this side and then dt is move on the opposite side. So leave it. So di by di of t di of t divided by I of t minus a1 divided by a naught into dt. Then take the integrations. I will going to apply the integrations. So when I will going to apply the integrations, so you will going to see that one. Okay, here is a so here both side you will going to apply the integrations. Okay, when you will going to apply the integrations di of t divided by I of t. So it's look like that one 1 by x. Yes or no? So 1 by I into di. So 1 by I into di. So 1 by x into dx. Okay, what is the answer? Log x. Okay, this term is a log. Okay, I of t. It is equal to what is that this side? So you will going to take it is under means it's only one nothing it is there. It's a only constant. Okay, so you will going to take means it is a one only minus a1 divided by a naught. It's a constant only. So minus a1 divided by a naught plus. So you will going to take the integration. So constant k1. So you will going to come write it on that these equations. After these equations, so you will going to substitute on the k1 place. I put it on the circle. In that one, what I will going to substitute? So k1 is replaced into the ln k. So ln k1. Okay, same name. Okay, ln k1 I will going to substitute it. So if I will going to substitute it, okay, you will going to get this equation, this line. Then you will going to see about that this box. Okay, ln x plus ln y, it is equal to ln xy. Ln xy. So two term is there. What are the two term? This is a term number 1, this is a term number 2. So these two term multiply. So this is multiply one terms. Okay, so see that one left hand side ln under the right hand side, so cancel. Then I of t, t is equal to k dot e power minus a1 divided by a naught into t. So this is about that one current equation of the homogeneous. So homogeneous current equations. Okay, further you will going to solve. What is the further you will going to solve means I will going to put it on the time period t is equal to 0. So t here is a 0. I will going to substitute it. If I will going to substitute it means e power 0. So e power 0 k dot e power 0. K dot e power 0. So k dot e power 0, what is the answer? So e power 0 means 1. 1 into k, it is equal to answer is k. 1 into k, the answer is k. Okay. So I will go to next. Okay. I will going to substitute the k is equal to a2. K is equal to a2. I will going to substitute. K is equal to a2. In that equation, first equation, I will going to substitute on the k point. So k is replaced into the a2. I is equal to a2 dot e power. This is the answer. So like you will going to complete about that one. You are going to learn about that one. Homogeneous. Homogeneous. What about the non-homogeneous? Non-homogeneous means you will going to comparison. That is a comparison based you will going to do. What is a comparison? See here. So a naught dot di by dt plus a1 dot I of t, it is equal to v of t. So this is a non-homogeneous first order equation. What is a first order equation? Di by dt plus pi, it is equal to q. So now you can compare these two. You will going to compare these two. Then you will going to write, you will going to find out what is a p value, what is a q value. This is a p value, this is a q value. So before you will going to compare, so before you will going to compare, you should be matched with that these equations. You will going to match with these equations. Okay, so is it matching? Means it is not matched. Why it is not matched? Di by dt, but here is a naught is present, here is no nothing is present. Here is a nothing is present. So what to do? I will going to, in the homogeneous first order equation, I will going to multiply e power p of t, p into t, e power pt. Okay, pt, it is that I will going to do the multiplication on that individually. So multiply here e power pt dot di by dt plus this pi is right, then e power pt, it is equal to q into e power pt. So this is equation number 1. Now you will going to see that once. Okay, is it matched? This one, yes, it is matched. Okay, in that one a naught place, a naught is there, a1. Okay, a1. Okay, there's a there. What is this one? What is a common? I of t, I is common. I of t, I of t. Okay, I. Okay, so p dot e power pt. Okay, so this is about that one. It is a matching. Then it is a v of t places. This is a v of t. Okay, so coming to that one. Okay, substitute into the equations. D of xy, it is equal to, what is the formula in the d of xy? X dot dy plus y dot dx. Okay, this is a formula. In that one, what is the x term? X term is I. Okay, and y term is e power pt. So when we will going to substitute under these equations. Okay, d by dt x y, x is I dot y is what is about e power pt, it is equal to x value, what is x, I dot dy, what is the dy, so differentiate with respect to the e power t, so differentiate with respect to e power t means e power pt dot p plus y term, what is the y term, e power pt dot dx di by dt. So this is equation number 2. Okay, from the equation number 2, okay, so 1 and 2 you will going to equate, so you will going to equate the 1 and 2, then you will going to whatever you are going to get, see that, so your this terms and this term is matched, so this terms and this terms when you will going to equate it is matched, then you will going to take this term equal to this terms, that is the term is written. Okay, from the terms you will going to take the, you will going to apply the integrations on both side and then simplify, you will going to find out the I, so I equations. How you will going to found the I equation of the homogeneous, similarly you will going to found the equation of the non-homogeneous I equations. So this is about that one prerequisites, you should be know mathematics about first order differential equation, from the first order differential equations, homogeneous and non-homogeneous. Okay, so these are the things. Let's we go to that our subject, I mean syllabus. Let's we go ahead. So this is also one more prerequisites. What you will going to know about the prerequisites? Integrations. Integration e power r by l into t. So if you are going to do the integration of that, this term means e power. Okay, this terms. Okay, this terms you should be right. Yes, I have right about that one. Into 1 divided by this terms. This is integration. Suppose differentiation means what you will going to do, e power minus r by l of t I got given, then the same terms you write on the same term into what is the e power value, so that one you will going to differentiate means minus r by l. Here 1 by r by l, here is a directly you will going to write. So this is a mathematics prerequisites. Okay, so let's be going to learn about one derivation today class. Okay, so RL circuits. Okay, but in that point I will going to teach you. Okay, in that derivation point. Okay, let's see, you can see here DC supply is there, switch is there, followed by resistance and inductance is there. So transient take place at the instant of t is equal to 0. So before the transient means switch is open. So when is the transient take place? When the switch is closed. When the switch is closed at the t is equal to 0 point, I will going to close the switch. Then this excitation DC source or battery, the battery is flow to the energy, battery energy, it is a flow to the circuit of the R and L. Okay, elements. So to find the transient response, t greater than 0 point only. Yes. So once it is closed, above 0 value, it will going to start to functions. So to find the steady state value of the current, okay, you will going to find out, to know the initial condition of the current. So what is the initial condition? Initially, okay, at the point of closing 0. So initial condition is 0. So let's see, we will going to learn about that one derivation, how I have derived. Okay, first one, apply the KVL. Kirchhoff voltage law. So what it is law? V is equal to, so V, this is a V1 and this is a V2. V1, V2. That's all. Kirchhoff law is saying, what it is saying, V it is equal to V1 plus V2. V1 plus V2. What is a V1? Or you will going to write some more clearly. What is a V1? V1 means VR1. VR. Okay, VR plus VL. Substitute VR plus VL. What is the equations? What is a VR? V is equal to, what is that one? I into R. I into R. Substituted. And then VL means what is the equation? L dot di by dt. Do I got substituted? Yes, I got substituted. So VR means I into R. VL means L dot di by dt. Okay. So this is about that one. Okay. So I into R, L dot di by dt. Okay. So you will going to write either directly, or I will going to write with respect to the t term. I of t, I of t. I will going to write. Here is a t is missing. You will going to write v of t. So this is equation number 1 is over. Okay. Then what to do? I will going to do. So I will going to divide the L. I will going to divide the L in the above equation. I will going to divide it. So if I will going to divide it means what will happen? So in that one L is there, so it will going to get the L by L cancel. So d by dt plus I of t, okay, r of t divided by L b by L is the equation number 2 I am going to get. Equation number 2 I am going to get. Otherwise I will going to do L by R equations. Sorry, what is that one? Otherwise, see here, or I will going to say mention about the r. So either you can divide it the L or you can divide the r. So either you can choose either two method you will going to proceed. Either the you will going to divide the L, you will going to simplify the equation derivations, or you can divide the r. If I will going to divide the r in the above first equations, okay, if it is a divide by r, so v by r, v by, so right, I will going to write it. So the left hand side, what is that one? V divided by r, it is equal to I of t. So r is cancelled, so I of t only. Then L plus L by r di by di of t divided by dt. Okay, this is the equations. Either divide by L you can proceed, or divide by R you will going to proceed. Why? Because these two term only. Either R term available or L term available. So here that one R is available or L is available. So I want to divide it either L or divided R. Okay, then what you will going to do? So I will going to, from once I will going to divide it, I will going to simplify. What I will going to simplify? So this right hand side, these terms only you can keep on the right hand side. L by R di by dt you can keep it. This is I of t, you can move opposite side. So when you will going to move opposite side, what it will going to come? V by R minus I of t. See here I have written. Then what to do? Next step, you will going to concentrate on these points. I will put it on the one circle. Here also I will going to put it on one another circle. This total term is move opposite side. Di by di of t divided by this total term is coming on the denominations, because it's a product, so it is coming on the denominations. So this term is a move on the opposite side. So 1 by dt. So dt dot r is coming numerator, L is coming denominator. Okay. So either divide by L or divide by R, you will going to do on the day. This is equation number 2. Okay. After equation number 2, this is the equation number 2. There is a two equations. Either you can proceed with this one or this one. Okay. Then what to do next step? Apply the integral on the both side. You will going to apply the integral. So even you will going to apply the integral, what you are going to get here? So already we were discussed ln. So ln. So 1 by x. So ln this v by r I of t. Then why do they mention about minus? Because here, so that's why minus ln v by r minus I of t, it is equal to, what about the integration here? R by L, okay, constant, integration of dt, so only t plus constant is a k. This is equation number 3. This is equation number 3. Okay, in the equation number 3, so substitute as usual t is equal to 0. Where is the t terminal is there? So t, so you will going to substitute into the t is equal to 0, t is equal to 0. Then you will going to get what you are going to get. So constant value you are going to get. Yes, k value you can get. So once you will going to get the k value, substitute into the same for third equations. Where is the k point? This is a k point. Substitute into the k equations. K is a minus ln v by r. Okay, once you substituted, okay, what you are doing? So here is a ln available, here also ln available. So ln you will going to move on one side. So this is a minus ln, you can move opposite side plus ln. It is equal to r by L of t. Okay, then I will going to change the sign. So plus minus minus. So replace the sign. Sign is I have changed. Then here ln is there. So you will going to simplify. This is a, this is a b. A by b. A divided by b. Okay. So this value a divided by b value b by r. It is equal to, the right hand side is as similar. Apply the anti-log. Apply the anti-log. So automatically ln is gone. Okay, this is a this equation. It is equal to e power ln anti-log. So e power minus r by L of t, which will going to appear. Okay, in the equation, what is the denomination is there? This one v by r, move into the numerator. So I have moved into the numerator v by r. same, left hand side is same, right hand side is same. Then after that, I want to keep it only I of t in one direction, I mean one side. So I will go to I of t only you can move. So this terms you can move this side. So v by r minus this terms I of t, it will going to come here as a plus. So this is equations. So here is any constant, v by r is common. So commonly is there, you can move outside. Then 1 minus e power minus r by l of t. So then r by l, it is a tau you will go to replace. Then 1 minus e power minus, okay, minus r by l is a tau. See r by l, see here is r by l is there, but tau is equal to l by r. Tau is equal to l by r. So 1 divided by l by r. It's nothing but a t divided by tau. So minus t divided by tau. So this is about the I of t. So this is a method you will going to find out the I of t. No problem. I will going to teach one second. Okay. Once I of t is find, what to do next. So what to do next means, so then you will going to find out the power value. Okay, power value. What is the power? Okay, power value. So P of R here, power value P is equal to PR plus PL, power value. What is the power value? Power P is equal to V into I. Then PR means VR into I of I. Then PL means VL into I. Then so you need to find out the VR value and VL value, and this is a method you will going to find out VR value and VL value. Then substitute the VR value into I value and the VL value into I value. Then you will going to get the PR value and the PL value. Then these two answer you will going to add, you will going to get the answer. This is the answer. This is the answer about that one. Okay. So what is that one? I of t. I of t. This is the answer. I of t. V by r 1 minus e power minus t divided by tau. Okay. I. Then V of r. R dot I of t. Take this one r. R is constant. Okay. Dot I of t. Where is I of t? This is a term. So take you will here write it. Then numerator denominator cancel. So V of r is a ready. Simple over. Then VL. What is a VL? L dot di by dt. L dot di by dt. Then I is substitute and then differentiate on that one d by dt on this terms. You will going to differentiate. Then you will going to get this answer. So due to the time constraint, I will going to stop here. Then we'll going to continue and we'll going to see once again for that this transient response derivation on next class.